Advent of Code 2018, Day 25, Part 1. You're given a list of points in four-dimensional space and asked to determine how many constellations they form, where points are connected into the same constellation when the Manhattan distance between them is no greater than 3. Here's some sample input as a vector of character vectors. Replacing the regular minus character with APL's unary negation symbol gives valid APL expressions, each of which can be evaluated to give the coordinates as numeric vectors instead of text. Each vector has length 4. If we name the first 2 points, we can find the Manhattan distance between them. Here's the difference between them, the absolute difference between them, and the sum of the absolute differences, which is the Manhattan distance. Doing this for all pairs of points gives a matrix of the distances between them. The zeros on the leading diagonal represent the distance from each point to itself. From this, we can start to build a Boolean matrix that represents a relationship between points, in particular, the relationship of being in the same constellation. To start with, we will only include points that are in the same constellation by virtue of being close enough to each other. An or.and inner product between this matrix and itself augments the relationship to include points which are in the same constellation because they are connected by one intermediate point. For example, if A is close enough to B and B is close enough to C, then B connects A and C to the same constellation. The inner product works by taking all combinations of one row vector and one column vector, anding them together, and doing an OR reduction on the result. If the two vectors correspond to points A and C, then anding them together tests all potential points B in parallel to see if they are close enough to both A and C, and the OR reduction tells us whether any such point B was found. Repeating this process until we reach a fixed point gives us the transitive closure of the matrix, which is the relationship we want. 2 points are in the same constellation if they are connected by any number of intermediate points. In this matrix, each row represents the constellation containing the corresponding point and is a bitmap of the points in that constellation. Hence, 2 rows in the matrix are identical if and only if the corresponding points are in the same constellation. Finding the unique rows of the matrix and counting them gives the number of constellations, 3. My full puzzle input has 1,248 points, so applying the same algorithm gives a 1,248 by 1,248 Boolean matrix. Counting the unique rows gives the number of constellations, which is 386.